Hi there guys, my name is Mark Davis, also known as MBD, and I'm here to bring you Methodoku Masterclass number 4. This episode is all about lead ends. Now, you might have spotted that lots of Methodokus have rules saying things like 4 working bells, or bells 2 to 6 do the same work, or 5 lead plain course. What do these mean? Well, these rules are actually saying something about the lead end, the last row of the Methodoku grid. Let's start by looking at an example, and I'll show you what I mean. This is a nice simple little 4-bell Methodoku puzzle, and if you don't know about Methodokus and you want to find out what they are and how to solve them, have a look at my Methodoku Masterclass number 1 video. But we're quickly going to solve this Methodoku following the standard rules, which are every number's a bell, every row has to contain every bell, and bells can only move 1 space at a time between rows. They can't jump. Right, so I'm quickly going to see that the 4 has to come down via this path. It can't jump any further, and so the 2 and 3 must go here. Then I think the 3, again, by the same logic, has to come down via this little route, and then there's really only 1 space left for the other bells. And the 3 must cross with the treble, with the bell 1. And we've very quickly done most of the Methodoku, but what do we do in this last row? Now, this last row of the Methodoku is, as I said, the lead end row. And there's all sorts of things that could happen here. I mean, the 2 and the 3 could swap, in theory, couldn't they? And the 4 stay still. But actually, that's never allowed in any Methodoku puzzle, because we've come back to 1, 2, 3, 4. We've come back round, and that would be a 1 lead method. And although there are a few 1 lead methods out there, Methodokus are generally not going to have those. So we're going to cross that out. I don't like 1 lead methods. But there are other things we could do, isn't there? I mean, in theory, all the bells could stay in the same place. 1, 3, 2, 4. And we've got no rule here which says that the method must be true. So we do have a repeated row, but there's no rule to say that that's not allowed. There are false methods out there, and there are plenty of Methodoku puzzles where their solution is a false method. So we could have that. And the other possibility, I think, is we could have the 3 staying in the same place, but the 4 and the 2 swapping. And that does look nicer, doesn't it? But looking nice, that's no good. It's got to follow the rules. And so basically, I think the answer is there isn't a unique solution to this Methodoku. So it's not a fully formed Methodoku puzzle. It needs an extra rule. And the extra rule you're likely to see is something like this. So 2 lead course. And that rule would say to us that we need a lead end here, so that when we repeat this lead, we get another lead and then it comes round. So there's 2 leads in the plain course. But how do we get that from here? How do we know we've got a row which generates a 2 lead course? Well, let's go back and look at some of the ones we've tried before. I think actually if we leave all the bells stay in the same place, that's going to give me a 2 lead course. But how do I know? Well, I could write the whole thing out. So the way that I do that is maybe first of all I write down the place notation for the completed grid. And again, if you need to learn about place notation, have a look at my masterclass number 2. But this is basically plain hunt to start with. So it's cross 1, 4, cross 1, 4, cross 1, 4. 1, 4 is the places made. It's the places made in the 1st and 4th columns of the grid. And cross means all the bears swap. And down here we would have a 1, 2, 3, 4. Everybody stays still, so it's a 1, 2, 3, 4 place notation. And so I could write that out here. I could start with 1, 3, 2, 4. So start where we left off. And I could follow this grid that we've already done. And I could see what I get down out at the end. So let's quickly do that. Cross, 1, 4. Cross, and 1, 2, 3, 4. And look, that has brought us back to rounds. We've repeated the lead. We've got 2 leads, so that's correct. It is a 2-lead course. But I don't really want to have to write out the whole of the method to work out how many leads. And you know, I could do that for a simple little puzzle like this, but it might be a surprise major, and it might take me a long time to write it all out. So what I want to do is look at this lead then row and try and predict how many leads it will generate. Now, the best way to do that is to write it out underneath rounds. So I'm going to bring in another piece of paper here, and I'm going to write out rounds, and I'm going to write the lead end row directly underneath it. And basically I'm skipping out the whole of this middle bit. That's the short circuit. Then I'm going to look at how the lead end row compares to rounds. And I can see that the treble and the 4 have stayed in the same place, and the 2 and 3 have swapped. So that's like a permutation. That's a rule for changing rounds into the lead end row. And if I repeat that permutation, i.e. 1 and 4 stay fixed, but the 2 and 3 swap, you can see I get back to rounds. And so that was lead 1, and this is lead 2, and that is a 2-lead course. So I've very quickly been able to show that without writing the whole thing out. And so that solves that Methodoku, doesn't it? But what if what if that wasn't the rule? What if the rule was something like this? Bells 2 to 4 do the same work. So clearly, in this example I've got here, bells 3 and 2 are swapping around with each other. So in the second lead, bell 2 will ring the work of bell 3, its third place bell, and vice versa. But actually, bell 4 will always keep ringing the same thing. It's actually what we call a hunt bell. So hunt bells don't have to plain hunt. I mean, this bell it's taking a plain hunting path through the method. But in general, a hunt bell just means it's come back to its home position at the end of the lead. Doesn't actually have to follow a plain hunting path. So in this method I've written out here, the 1 and the 4 are hunt bells. In most methods we ring and most Methodokus we solve, the treble is the hunt bell. But not all. Sometimes other bells can be the hunt bell, and sometimes there can be more than one. Obviously, Grancer is a fantastic example of a method where there are 2 hunt bells. But it doesn't even have to be the treble, you could have 3 and 5 as hunt bells. And the bells that aren't hunt bells, the bells that are kind of changing position at the lead end, they're called working bells. So in this, I've got the case that bells 2 and 3 are doing each other's work, so they're doing the same work, but bell 4 isn't. So this lead end no longer matches that rule. So let's rub that out. I'm making heavy use of my rubber here, which is a pretty normal thing to do when you're solving Methodokus, so don't worry. Now, what other options were there here? So, as we said before, I can't just swap the 2 and 3 and leave the 4 fixed. That gives rounds. That's a 1-lead method. That's no good. Certainly, all bells are hunt bells there, and they're not doing each other's work. But I could have the 3 make seconds and the 4 and the 2 swap. And actually, I hope you recognise that now. That's actually plain bob, isn't it? Plain bob minimus. The 3 hunts and then makes seconds. The 4 hunts and then dodges 3, 4 up, and the 2 hunts and dodges 3, 4 down. So we know that the blue line of plain bob minimus, the bells 2, 3 and 4, they're all going to cycle around and do each other's work. There's an order of work, isn't there? But how do we actually know that? Just by looking at this lead end, 1, 3, 4, 2. Well, again, I'm going to write that out underneath rounds. So get another piece of paper. Rounds. And we're going to write out the lead end, 1, 3, 4, 2. And again, I'm going to see how the lead end has changed things compared to rounds. So again, the the treble bell 1 has stayed in at the same place, but bell 2 has hopped to the back. So bell 2's gone to 4th place, and 4th place bell has gone to 3rd place, and 3rd place bell has gone to 2nd place. So those 3 bells, they've kind of rotated round, haven't they? Like that. And I can repeat that permutation. So bell number 1 stays fixed. The bell in 2nd place goes to the back. Bell in 4th place comes down to 3rd place. Bell in 3rd place comes down to 2nds. And so you can see that the 2nd lead end, it's not rounds yet. So we need to keep going, keep doing that permutation. So 4 goes to the back, 3 comes down, 2 comes down. And after a couple of repetitions, after 1, 2, 3 leads, we've come back to round. So we've got a 3-lead course. And in that course, you can see, for instance, taking bell 2, it's done 2nd place bell in this lead, it's done 4th place bell in this lead, 3rd place bell in this lead, and it's come round. So it's gone through and it's done all the place bells. And so with this lead end, bells 2 to 4 have done the same work. So that works. So that's brilliant, and actually, hopefully that's relatively easy for you to see. But it does get harder, and there does get more possibilities as we go on to higher numbers of bells. So we'll look at something a bit more tricky next. We'll look at some 6-bell problems next. Now I'm not going to show you a Methodoku for this, I'm just going to show you lead ends. So let's have a look at this one. And these are the lead ends that you might get to at the end of a Methodoku, or in that last row of a Methodoku you might be looking at thinking whether that works. And whether it matches one of the rules about the number of leads in the course or the number of working bells. So what do you do when you've got a lead end like that? How do we tell how many working bells there are? How do we tell how long the lead is? And the answer is just as we did with the minimus method. We put that underneath rounds and we compare it to rounds, and we can work it out from there. So I'll do that on this side here. There's rounds, and underneath we'll put our row. And we're going to compare it and do just what we did with minimus, and we see, the bell in 2nd place jumps to the back. The bell at the back goes to 4th place. The bell in 4th place goes to 5th place. The bell in 5th place goes to 3rd place. The bell in 3rd place goes to 2nd place. So basically, all of those bells are working bells. They all move to a different place. There's none of them staying still. There's no hunt bells other than the one. And that's going to generate, I think, because there's 5 bells, it's going to generate a 5-lead course. But let's try and repeat this permutation, and just to check. So that's rounds, and that's the first lead. Obviously, every lead is going to have, in this method, is going to have the treble at the front. You will find a few Methodokus which mix the treble in, but mostly, like most methods we ring, the treble's fixed. So I'm going to follow the same permutation. So the bell in 2nd place goes to the back, and the bell in 6th place goes to 4th place. And you can see how I'm pairing up, the jump of this bell matches the jump of the bell just above it. So the bell in 4th place went here, and so that's where the 6 goes. I want to do the bell in 5th place next, so I need to follow what the bell above, what the bell in 5th place in the last permutation did. And then 5 goes down here. So I hope you're following that. I'm just jumping the bells around in the same order that happened in this first change. And when I go to do we haven't come round yet, so we need to keep going with that. When I do that here, it's actually easier, I think, just to look at the row above. So I look at the 5 first. What did the bell above it do? Well, it went to the end. So I'm going to put the 5 there. You can, of course, look back up to rounds and see where the bell in 2nd place went. But actually, it's easier for my eye just to look to the row above, because, if we've done it right, every row will be the same permutation. So where does the 3 go? Well, the bell above is the 2, and that went here. So we follow it. The 2 goes where the 6 went. 6 goes where the 4 went. And the 4 goes where the 5 went. All right, so we're getting there. We need to do a few more permutations, though, and I'm getting a bit quicker at this because I've got my eye in now, and I can see, the order that things are changing around in. It's always the same, like that. And after 1, 2, 3, 4, 5 leads, we've got back to rounds. So you can see that's a bit more complicated than the minimus. There's more numbers there, and your eye can get confused. But if you follow that rule, looking at the bell above, where did that go, and following that in the next row, then you can work the permutations out. And the common sense was we had 5 working bells. They each seem to cycle through all of each other's work, so we ought to have 5 leads, and that's indeed what we've got. Let's look at a slightly different permutation now. Let's look at this one, because 5 leads is not the only option. So what happens if we swap the 4 and 6 round? So I think, is that going to do the same thing? Is that going to give us a 5 lead course? And I think the answer is no, isn't it? Because I can see, again, I'm going to write the rounds just above it. I can see the 4 is staying in the same place. So the 4 is a hunt bell. And there's only 1, 2, 3, 4 working bells. So definitely can't be a 5 lead course. It's probably going to be a 4 lead course, isn't it? But we'll run through the permutations and check that in the same way. So 1 and 4 is staying still. 3 goes under 2. 2 goes under 6. 6 goes under 5. 5 under 3. And let's repeat that. Okay, we've got 3 leads. Is it going to come round? Yes. Okay, 1, 2, 3, 4. So that seemed to work. And that's good. So, sometimes if you get your eye in, you can easily work out how many leads just by looking at that first lead end without having to write all this out. Here I can see, 1 and 4 hunt bells. These are the only working bells, and they all kind of cycle through each other's places. So it must be a 4 lead course. But you do have to be a little bit careful. So let's look at another example here. And again, we can see here the 1 and the 4 are hunt bells. So let's write rounds up above them. 1 and 4 hunt bells, and we've got 4 working bells. So we might think, well, 4 working bells, they're probably going to cycle through each other's work. We might have 4 leads, but let's try it. So 1 and 4 stay still. 6 goes under 2. 2 goes under 6. 5 goes under 3. 3 goes under 5. And we're back to rounds after just 2 leads. And the reason for that is that these bells weren't all doing each other's work. So if you had a rule saying all working bells do each other's work, that wouldn't be the case here. All working bells don't do the same work here, because the 2 and 6 are swapping, and the 3 and 5 are swapping with each other. So they're separate blue lines, effectively. The 2 and 6 will do a couple of leads of their own blue line, and the 3 and 5 will have a separate set of blue lines of a couple of leads. That's called a differential method, where you've got kind of different sets of working bells. And actually, again, if you write it out like this, if you follow the permutations, you'll find that out. But you can sometimes see it by eye. You can see that this is a pair swap between the 2 and the 6. So it's 2 and the 6 are never coming into 3rd and 5th place. Going to give you one more example, and this again is quite a fun one. Have a quick look at it, see if you can figure out what that does. So the lead end 1, 6, 5, 3, 4, 2. It looks like, to start with, well, there's no hunt bells other than the treble. So it looks like that should be a 5 lead course, doesn't it? But again, if you look closely, you can see the 2 and 3 are swapping with each other. The 2 and the 6. So actually, even a quick visual inspection of that maybe will get us worried that this isn't going to be a 5 lead course and not all bells are doing the same work. But let's quickly write the permutations out. So 6 under 2, 2 under 6. Those 2 bells are actually back rounds, but the 3, 4, 5 do something a bit different. So 5 under 3, 3 under 4, 4 under 5. They're rotating round, aren't they? So they're not rounds. So let's keep going with the permutation. Bells in 2nd and 6th swap. These bells rotate round. And actually, those 3 bells, 3, 4, 5, are back rounds, but now the 2 and the 6 aren't. Okay, so let's keep going with the permutations. Okay, we're still going. This is the 5th lead we're coming up to now, and obviously the 2 and the 6 are are going to be swapped round. So, we've got to keep going for more leads. But now they come back, and the 3, 4, 5 come back, and finally we've got back 2 rounds. And actually that took 1, 2, 3, 4, 5, 6 leads. So you can have, a 6 bell method with the treble as hunt bell with more than 5 leads, with a type of differential method where you've got different sets of bells doing different work, ringing different types of blue line. And here we've got the 2 and 6. They're doing a whole lot of blue line of their own, and the 3, 4, and 5 have got a separate set of work. And you will see Methodokus like that say 6 lead course for a 5 bell method, and you've got to look for something like this where you've got a couple of bells swapping and then 3 bells rotating around through each other's work. Right, so I hope that helped. I hope that helped you learn how you work out how many leads in a methods playing course just from the lead end, and how it helped you understand about working bells and when working bells are doing each other's work and when they're in a little group doing their own work. So all those things are really useful for Methodokos. And you might think, well, that's a lot of effort and a lot of work just for the last row in the Methodoku. I've done all the rest of the Methodoku, and it's only this last row I need to work out all these complicated rules for. But there's more to it than that. Next time, we will cover Methodokos with the symmetry rules, like palindromic symmetry, which simply means, the whole lead is a reflection of itself from top to bottom, and that means the blue line is a nice top to bottom reflection. And in methods with that kind of symmetry, which we'll explain next time, what happens at the lead end can affect what happens in the middle of the lead. And that's why these lead end rules are so important. Okay, hope you enjoyed that, guys, and I'll see you next time for the next episode of Methodoku Masterclass.